I am going to be going through the basics. You are writing this down, and I shouldn't be making you write as I'm talking, but anyway, we'll do it. So do we all know the lesson in how to draw a 3D shape? The artistry of it? Draw the rectangle, and then send it back, make them all parallel, connect. So nice and simple, right? So you do that. So this isn't new work, but it is more practice on the same work that we've been doing to apply it. So it's a different application. In your test, you are going to be having Pythag, right angle trig, non-right angle trig. We've talked about this before. It's on DayMap, the formulas that you will be allowed. Now on OneNote, I can't go and open that up on the video because all your names pop up. But if you go and see OneNote, there is a thing called more trig. So they've got some more just different types of questions from your book. You only need to look at those once you've finished your review sets. There's also then I think it's called revision. Go in there and there's a practice test from before that you might want to try and do. And then there's another one. One's got solutions, one doesn't yet. I will pop the second solutions up. The first test does, I think, combine right angle and non-right angle. The other test, we were able to split it and have two, so it's just focusing on the non-right. But it gives you enough. I would not be looking at those until you have thoroughly worked through the revision questions, done a couple of the ones from the more trig and got them under control, and then do the test under test conditions, okay? That's really important. So, are we all good with this? So let's begin. AG, we want to find the angle that AG makes with BG. What was the first thing that you would do? Draw the lines, absolutely, right? We don't look and get panicked. We just go, okay, we've got AG and we've got, oh, that's not very good, and BG. I've done it in a different colour, clearly. Is there another line that I should actually draw just to keep my colours nice? Pardon? Yeah, the bottom one. Just so we can see that triangle. And then we have to ask ourselves is, are we dealing with a right angle triangle or a non-right angle triangle? Non? Why? Why are we going non? Yeah, see, I reckon there is a right angle. That's right. It's got to be down here, otherwise the box is splitting open. Okay? Sorry. Yep. So Noah, just remember what I asked first. Is there a right angle in there? You're talking about find the angle that AG makes with BG. Yes, we're trying to find that angle there. That is not a right angle. Is that what you meant? Yeah. So you can attack it like that if you wanted to. Sometimes it helps if you just draw it and then you can actually see that it's a right angle triangle. That's our A, that's our G, that's the theta that we want, that's our B. Now, in order to find an angle with a non-right angle with a right angle triangle, we need two lengths. Do we have two lengths? And I'm just talking to go through what's going through in our mind here. Okay, I've got a yes, so what lengths do I have? So A to B is 12, and that's another tip. If you find that diagram up here hard, make sure that you've labelled your sides so then you can suss which is which. Correct? And so that comes into when we've got GB. Could I say that that's 6? I could not, because that's GC. So that's why it's really important that you label. So do I know another side? I've got to have another side if I want to find that angle. I don't have it. Can I find it? Yes. How can I find it, Blako? Yes, Pythagoras' theorem, because if we're looking here, we've got another right angle triangle hither, correct? Who doesn't even need to pull out a calculator to tell me what BG is? Brilliant, Mountain Man. Why have you gone 10? Oh, he doesn't know. Okay, I'm going to take that brilliant back a little bit. He is right. It is 10. Why can we say it's 10 just from our knowledge of Pythag? It's your 3. Oh, not even. I'm just going with my 3, 4, 5 triangle. So the most basic Pythagoras's thingy is your 3, 4, 5 triangle. And can you see that this is a multiple of? So 3 times 2, 4 times 2, and that would be 5 times 2. So I know that that's 10. Put it in the right spot. GB. See what I just did? Did you see what I was just about to do? Make an error? I was going to go, oh, here, and put it here. No, GB. Okay? Don't need that. If obviously they weren't very nice numbers like that, we would be saying to find GB, GB squared is 6 squared plus 8 squared. How do I get rid of the squared? Square root. And if they were not nice numbers, I would just leave it as root. If it was, let's say, root 101, I would leave it as root 101. I wouldn't get a decimal answer because I'm going to use this in another calculation. So I'll try and keep my answers exact. Does that make sense? Tom, staring out the window. So now, can we find our theta? Yep, put your minds back to your right angle. You've just been doing a whole lot of non-right angle stuff. So what rule would we use? Tan, very good. Opposite. Adjacent. Tan theta equals opposite over adjacent. Therefore, tan. I made a massive faux pas yesterday when I was doing this because I had someone in the class. It's not an excuse, but I was having people looking out the window. So I was focusing on them, saying, pay attention. And then guess what I did? Instead of saying 12 over 10, I did. So always make sure that you are checking your work, okay? And so that's going to be 12 over 10. I don't want tan. How do I get rid of it? Inverse. And I love that you're saying the language nicely. Very good. Inverse of 12 over 10. And huzzah, we get our angle. Agreed? Please do. Okay, your turn now. So, your turn for B. I'm handy on the board that I can obviously just get rid of and use a different colour. So we'll go green. We want to now find the angle that DF makes with DB. So we've got D to F. Oh my goodness, I don't know why I'm doing a curvy line today. D to F and D to B. So where is my triangle here? Where is my triangle here? I'll ask again, boys being boys. Where am I dropping my third side? Oh, clearly, has to be B to F, right? And so the question we're asking, is it a right angle? Yes. I've got a yes and I've got a no. So people who are saying yes, where is my right angle? DBF. That's right. It's got to be the bottom, right? Otherwise, the bottom is going to be, sinking. It's not flat. Correct? So we've got our right angle triangle. We want to find which angle. Where am I putting my unknown? The angle that DF makes with DB. DF, DB. Here. And we're being careful because I'm not putting theta here. Why not? Why can't I put theta? I've already used it. Correct. So alpha. Suss what information you have, what information you need in order to find theta. Go. A reminder, please. So when you do this, I've just gone 8 squared plus 12 squared, so 64 plus 144, right? We know that that's 208. Just be aware for people who are using graphics calculators, when you do that, if you just typed in square root of 8 squared plus 12 squared, right? And I'll do it now. You will not get root 208. You get 4 root 13. Now that's because 16 times 13 is 208. Remember we talked about how your calculator simplifies surds by looking for square numbers that go into. So if We've got people mixed in the class out here. You can just keep it as root 208. If you've got your graphics calculator, then by all means, you can just leave it as 4 root 13, but know why that is so. Correct? So if I'm now looking at that, oh, I did it the wrong way. Clearly Friday for me. 6. We've now found that this thing here is 4 root 13 because that's my D, that's my B, that's my F, and I'm wanting to find this angle. We can happily go ahead and go tan, bloody, bloody, blah, correct? If you had rounded this off, the 4 root 13, you could end up with a slightly different answer because of using a rounded answer in another calculation. Okay, tan to the minus 1. 6 over root 13. Oh, I did it again. No, I did. I was good. 6 over, I thought I'd switch them. 6 over 4 root 13. 22.6. Okay. So if you would like a bit more practice with 3D shapes, you've got an exercise 12G to go back and practice. If you go, oh my God, it's just Pythagoras and I can see where the right angle is, and then it's just right angle trig. If you don't need a whole heap of practice, you can just go ahead. Maybe I suggest you do one more. Please sit on my chair properly. But I think we've all got work to do. Agreed? Love your work, love your style. Go for it.